This is the first question. Like, this came in GATE 2022. So, in this question, you are asked to find out the total angular momentum of the ground state of oxygen. This, right? I've already told you, like, if it is an even number, so don't take this into consideration. You have to only find out which one is what, proton or neutron. So, see, in this, proton is 8. Number of protons are 8. And now you need to find out number of neutrons. So they are 17 minus 8 is equals to 9. So now we start filling the subshell. 1 is 1 by 2. This is the picture. Look, like Harish, you told me, na, to provide that table. So this is that. 1d 5 by 2. No, now start filling. So this will accommodate 2 neutron, and this will 4, this will 2, and this will 4, 5, 6, 7. So 8, 9, 2 will go here, right? 2 neutrons will go in this subshell. So where 4, oh, sorry, 1, 1. So J is 5 by 2. And now you need to find out the parity. So parity will be minus 1 raised to the power L. So you know S, P, D, F level. So L is equals to 0 for S, L is equals to 1 for P, and L is equals to 2 for D. So here it is D. So minus 1 raised to the power 2 is equals to positive. So that means 5 by 2 positive. So this will be the answer. So this I have already taken in the previous classes, but just for revision. And now the next question is yes. Uh-huh. Okay. See. Hmm. That you have to learn. That you have to memorize. Okay, this table. Now the next question is again very easy. So here one reaction is going on. So this is pi positive plus proton decaying to k cation plus some particle that we don't know. So we need to find out the quark content of that particle. Okay, the quark content of k positive is given to us us bar. So you need to find out the quark content of this, right? Now you know very well when some reaction is when some interaction is going on. So what you need to do, you need to just see some quantities that are conserved in a reaction, okay, in a interaction. So first of all, see charge. See here, first you will go for charge. So charge here in left hand side, it is, if you see, in left hand side we have positive charge, and here also it is positive, so it is positive, so this should also be positive, right? And spin, you know the spin of pion is 0 because they are bosons, and for proton it is half, for cation it is 0, so that means technically it should have spin 1 by 2. Now baryon number. So baryon, you know, pion is a meson. Pion is a meson. So baryon number for pion will be 0. For proton, it will be plus 1. And for cation, it is again 0. So for this, it should be plus 1. And now I. So I will be, you know, that there are pion, pi 0, pi negative. So they are 3 in number. 2i plus 1 is equals to 3, isospin. 2i is equals to 2, I is equals to 1. And Iz will vary from minus 1 to 1. So for pi positive, I value will be 1. Here it is written wrong, it is 1. And for proton it is 1 by 2, and for cation it will be 1 by 2, because cation has two particle, k positive and k zero, so they will give I is equals to 1 by 2, so it will be 1 by 2. Yes. Hmm. No, these two are two, these two make up two particle, and these two are different. Huh. That these the other two will make another multiplet, not they are not combine, you don't need to combine them, they are separate. Means k positive will go with k zero, and k bar zero will go with k negative. Which one will, I don't think so there is any rule, because I have not heard of any rule like which one will form multiplet, which one will not. Because generally we take p and together we take delta, sigma positive, zero negative as a triplet. So I'm not remembering any rule about it. Strange. Strangeness. Yeah, maybe strangeness will play a role. That strangeness. That strangeness you can find from Gell-Mann-Nishida rule, right? Q is equals to I3 plus B plus S by 2, if you know the other terms. Moving on. So it will be 1. Here it is written wrong. It will be 1. Now I3 will, I3, this will be plus 1 for it, plus 1 by 2 for it, and plus 1 by 2 for it, and plus 1 for it. Strangeness same. Strangeness is 0, 0 for pion and proton. And for cation, it is plus 1. That you will find from here. Q is equals to I3 plus B plus S by 2. Q is the charge. I3 we have just found out. And B, baryon number. So from that you will find S. So now see any particle which have Q 1, spin 1 by 2, baryon number 1. Which one will be that particle? Huh. X S, yes. UUS, yes. Yeah, true. I am teaching you in a traditional way. Like this is the conventional way how to approach this question when we are teaching in the class. But yes, in examination hall, you don't need to follow this whole long procedure. You know very well that quark content, sorry, strangeness should be balanced on both the side. And in left hand side, you are saying there is no strangeness, and in right hand side, if you are saying that there is S bar, so definitely you will require S to balance it, right? So here you can see there is no S here, no S here, and there is S bar, but S bar you already have. So you need S. So the only thing left is UUS, and that UUS, it is a baryon. So you know very well that baryons are made up of three quark, and mesons are made up of one quark and one antiquark, right? And here you can see that pion is already meson. Pion is already meson, and P is baryon. So K cation is meson. So here you will require the baryon. So this is a simple way of doing this question. I hope this is understood. And the next question, this question is also very easy. Angular momentum is R cross P, right? So if we are asked to find out Lx, so we'll do L is equals to R cross P is equals to Lx, Ly, Lz, right? This is X, Y, Z. This is Px, Py, Pz. Now, if you are asked to find out Lx, then this will be Yes. Huh. Huh, that you can solve direct. I told you na that what all you have, you know the shortcut, you can apply the shortcut in the examination hall. Yeah, true. So this is commutator relation that I am applying. So this will go zero. Obviously, this will also go zero. This will go also go zero. Now we are left with y, py, pz, and you know y py is eta h cross pz, right? So this is the answer. These all questions are very easy. Now this question I have taken all this question in earlier because these are just revision questions. Now this question one of you have asked me this question. So she was asking, I mean Aparna. Aparna is there? Okay, so you asked me this question, right? So in this question, if you see, electric dipole transition is going on. So you know there is an alpha decay, there is a beta decay. So suppose your nuclei is going alpha decay. Okay. So after alpha decay, nucleus will be in the excited state. And same goes for in the case of beta decay. So if it wants to come to the ground state, it will emit radiation, gamma radiation, right? And when it come to the ground state, your nucleus is a charge because it contains proton and neutron, right? Now this proton and neutron, their potential at any point x can be extended as Vx is equals to, there will be some term like we can extend their potential at certain distance like this, 1 upon 4 pi epsilon naught qi upon r naught plus 1 upon, sorry, capital R, 1 upon delta e qi cos theta plus some other terms. Now this potential will contain both electric dipole, electric transitions, as well as magnetic transition. But in this question, we are asked electric transition, right? Electric dipole transition. And it is given E1. 1 means L is equals to 1. Orbital angular momentum is 1. So now in the question, the total angular momentum is given 2 positive, right? And in the final state we are asked to find out all possible value. Okay, so you know that L is 1, and for electric dipole parity is given by minus 1 raised to the power L, and minus 1 1, that means parity will change. So from that you can cross, you can eliminate these two because parity is not changing in it, right? Now we are left with these two options. Now delta L is changing by 1, right? So to find out delta L, we will do Ji minus Jf to Ji plus Jf, right? So this will be like minus 1 to 1 because there is a delta L is 1, minus 1 to 1. So minus 1, 0 and 1 will be three values. Now if you see here, when you subtract 2 minus 1, you will get 1. When you subtract 2 minus 2, you will get 0. When you subtract 2 minus 3, you will get minus 1. So that means D is the answer. Okay? Which last? because minus 1 to 1 it is changing na. Now next question is this. Again you ask this question, right? So this is also like the transition line as shown in the figure arises between this and this without any external field. The number of lines that will appear in the presence of weak magnetic field. Weak magnetic field. Yes, yes. The reason being, I'll tell you. So see, yes, because in weak magnetic field, LS coupling won't break. LS coupling will remain the same. Only J will split. Like 2D 3 by 2, this is J, na? This is J. So it will be like, it will split into 2 into 3 by 2 plus 1. Four values, right? And these four values vary from minus 3 by 2, 3 by 2, right? So minus 3 by 2, minus 1 by 2, and 1 by 2, and 3 by 2. These four values. Again, P1 by 2 will again split into two values, and they are minus 1 by 2 to 1 by 2. Now you will form like this. So this will go 3 by 2, 1 by 2, minus 1 by 2, and minus 3 by 2. And here, and here you have 1 by 2 and minus 1 by 2. And one more selection rule is delta mj will vary from will take value 0 and plus minus 1. This you have to keep in mind this. So now see, if it is going here, so 3 by 2 minus 1 by 2 is giving me 1. Okay, but if it is going here, so that means 3 by 2 minus minus plus 1 by 2 is 2. That is wrong. So this will not go. Now 1 by 2 will go here. 1 by 2 will make transition here. Same goes for minus 1 by 2 and minus 1 by 2. And 3 by 2 again will make transition from minus 3 by 2 to minus 1 by 2. So they will make two transition, and these two will make only one. So that means 2, 4, 5, 6. 6 is the answer. I hope this is clear to you, Aparna. Aparna. The next question, this is asked by Harish. Though the question is not clear, but I'll tell you. Harish is there? Okay, okay. Now I'll start this question. So this is quite lengthy question. So from where you got this question? Gate question. In which year it came? Okay. So see this question. A beam of identical particle of mass m and energy E is incident from left on a potential barrier of width L. Okay. So this is the potential barrier, width is L. 0 to L. Height is V naught. For x greater than L, there is a tunneling with the transmission coefficient this, and A Z not A R A T describe the amplitude of the incident reflected and this way respectively. Now throw 0 to x to L. The wave function will be, can, yeah, huh. So it will be exponential. Yes, exponentially. Yes, true. Because it will be exponentially decaying. This is true. Because here if you see, now in all three reason, if you apply Schrodinger equation in all three reason, huh? So in the first reason, you will get exponential, not exponential, complex terms. In second reason, you will get exponential function. In third again you will get like complex. So if you see for the second reason, you are getting exponentially decay because the probability of finding the particle in that reason when E is less than V will be exponentially decaying. So for this question, the answer will be exponentially decaying. So it will go like this way. Um, this is like this. So this is 0 L. So first it will be like, then it will go like this way, then again it will go like this. Now, for this part, 72 part, let the probability current density associated with the incident wave be S naught. So, the probability current density associated with the incident wave is S naught. Let R be the reflection coefficient. Then you need to find out the which one is correct. So first is the probability current vanishes in the classical forbidden reason. It is not true because we know that tunneling is the process is a quantum mechanical process, right? So classically tunneling is not allowed, but quantum mechanically it is allowed. So there is some probability of finding the particle, and that probability is decaying exponentially, right? Now the next D is for x greater than L, the probability current is a complex, and B is the probability current is Ts naught for x greater than L. This is wrong. No. We'll see. We'll see second B why the probability current is Ts naught for x greater than L. So first let us solve the probability current associated with the incident wave S naught. So find out S naught value. You know S naught is minus, I'll do here. See here, incident is A e raised to the power k1x, right? This is incident. So if you are asked to find out the probability current density for incident, so it will be minus eta h cross upon 2m psi star psi I star del psi minus psi I del psi I star. Okay? When you will solve it, when you will solve, right? So you will get S naught is equals to the value you will get k1 h cross upon m a square. This you will get. Now here if we see t, and t is the transmission coefficient. So t if you see, t is again amplitude of e square upon a square is t, right? If you again find out e, so you will get transmission current density like this way. Minus eta h cross upon 2m psi t star del psi t minus psi t del psi t star. So when you will solve it, you will get k1 h cross upon m e square. This you will get, right? So what is given? So it is given the probability current is Ts not for S for x greater than L. That means in this region, this is the transmission region, third region, right? So for third region, it will be, if suppose I'm multiplying it by a square upon a square, right? So this will become, am I doing some calculation mistake or something? Huh. the probability current density in the third region. So this is not T, this is current density. Sorry, this is current density in third region. So if I multiply it by a square upon a square, huh? So, huh, huh, then we will get, yes. So this will become T and this will become S naught, because just now we found out K1 H cross upon M A square is S naught. So this option I am finding it correct. I don't know what is written here. I, is it I or plus, is it I or 1? So Harish, you can clarify it whether it is I or 1. And for x greater than L, the probability current is complex. So it is not complex. You can see here it is not complex. It is a real number. Huh. So it is not complex. So I think B is the correct answer. So you can clarify whether it is I or 1 for C, but when I solved it, I found out that B is the correct answer. Because here you can see if you multiply current density for transmission region is E square. It came like this. K1 H cross E square upon E square upon M. This is current density for x greater than L. Na? If you multiply and divide it by A square, so what you will get? E square upon A square is T, na? Transmission coefficient. Now you are left with this K1 H cross upon M A square, and you know it is S naught, right? So T S naught is the answer. Now, I hope this is clear to everyone, because this question was also that I have just kept photos from, this is from Zetli book, huh? This is from Zetli book, Zetli for quantum mechanics. Okay, so some extra portion I also included for your learning. Huh? Huh? C. What is C? The then it is wrong, because if it suppose it is S is equals to 1 plus R, then it is correct. If it is I plus R, then it is wrong, because I was solving this question, so I have taken both into consideration. When first I took 1, so then it was correct. Hmm. But when I took I, then it was wrong. So if it is 1 plus R, then it will be correct. Okay. B. So in this, B answer is correct because it will be exponentially decaying, and in it also B is correct. Now for this question, the ratio of reflected to incident amplitude. Um, Amplitude, it is, so we have to find out E by A and B by A, right? Because reflected to, what is asked? Reflected to incident amplitude. That means where it is reflected to incident amplitude. So that means we are asked to find out B by A, because this is incident, and this is reflected, and this is transmitted. Okay, this is incident, this is reflected, and this one is transmitted, and the amplitude of it is A, and amplitude of reflected is B, so B by A, right? We can find out the square of it, like reflection coefficient and incident transmission coefficient. That will be fine. After that we can do square root. So by that, if we go here, I feel like, so I have not solved this question, but I feel like the answer would be this one, D. D will be the answer. You can do this question, because I feel like this one will be the answer. A real negative number will not be true. This is not correct. 1 minus 80 by, what is this? 80 by A naught. 1 minus 80 by A naught means reflection square is equals to 1 minus, if suppose I am doing it, reflection 80 AR by A naught is equals to 1 minus 80 by A naught, if suppose I am doing. If I'm squaring both the side, so that means AR not square is equals to 1 minus 1, sorry, 1 plus 80 by a naught square minus 2 at by a naught. Okay, this will come. Hmm. Then if you can see here, you can put the values of ar by a naught. Ar by a naught is this b by a square, huh? Here the terminology is different. So ar is b, a naught is a, and at is this e. Okay, so and reflection will be a r by a naught whole square, right? So reflection, what you got r value you can put here. So r value, what I got, this value I got, and this is t value I got. And further, while further solving, they got r and t value like this. So you have to do a lot of mathematics in this one. Try to put what I got from here. 1 plus, okay. So r is equals to 1 plus t minus 2, then 80 by a naught. 2 t under root 2, 1 by 2, na? So try to put these value in this, these two values in this. If right hand side is equals to left hand side, that means answer A is correct. Okay, I can do this. R is equals to 1. Try to solve right, this side. 1 plus t is this one. Um, huh. So you got the point, na? Right? How to solve it? If suppose I divide whole of this by t. So r by t is equals to 1 by t plus 1 minus t 1 by 2. So r by t is given. R by t is this one, na? If t is coming to the left hand side, so r by t you got. And now 1 by t. So t is this. So t is 1 upon something, because this is minus 1. So 1 by t will be equal to 1 plus 1 by 4 and this whole term, right? And again this will be 1 by 2. So you can solve it. I mean, this is quite easy looking, I feel like, because some mathematical things will come, but my main point was to give you the hint like how to solve this question. So that is why I have given all the formulas, all the values which you need to put and solve. And this, I also feel like, uh, I also feel like this is so lengthy. And now if we see here this one, I feel like this is the answer. I don't know why. B there, B is given. Hmm. Hmm. Reflected, transmitted wave. Hmm. Hmm. One is, हाँ, root over R, ना? Okay. हाँ. Maybe they have applied the same logic, because if we go by traditional way, then it will be very time consuming, like half an hour. So they have asked like amplitude, na? So square is amplitude. We generally take square. So yeah, r is equals to one. Nee, one is equals to r plus t, and r is equals to one minus t. 1 minus t. So if we go by this way, and this is a square, r is equals to r is equals to b by square. If we take square on the that side, then it will be 1 by 2, right? Yeah. B. Uh-huh. Hope so they have applied the same logic, because otherwise there is no way of solving this question by conventional way. I hope so, Harish, you got the idea of how to solve this question. Then next question again you have asked this one, right? I saw this question just now. I thought of including it. So this question is quite mathematical. Here, if you see, consider an electron in a box of length L. This is electron in a box of length L with a periodic boundary. This. If the electron is in the state this, right? With energy, Ek is goes to h cross k square upon 2m. What is the correction to the energy to the second order perturbation theory, which is subjected to the weak potential? Where is weak potential? This is weak potential, where G is an integral of 2 pi by L. So now you have to find out the second order correction to the energy. So you can apply En, this is second order, psi n, psi kx, and take n. Then h psi k x upon e k0 minus em0. This is without perturbation energy, which is given to us without perturbation energy, right? Now, if you solve this, the difference of both, yeah. If you solve this, right? So you need to solve. Then you will get of psi is e raised to the power minus iota mx root L. H will be e won't be there. There will be v because it is subjected to weak periodic potential. So v naught cos gx, k is e raised to the power iota kx root L dx, and the limits will vary from 0 to L. Now v naught by L, sorry, phi m vx phi k is equals to v naught by L 0 to L. This will be e raised to the power iota k minus m. E raised to the power iota k minus m x cos gx. V naught is cos gx dx. Okay, and it will become v naught by L 0 to L e raised to the power iota k minus mx e raised to the power iota gx plus e raised to the power minus iota gx upon 2, right? I can write cos gx like this way, right? Then v naught by L 0 to L k minus m x, 2 I'm taking outside, e raised to the power iota gx plus e iota k minus m gx dx. V naught by 2L is equals to, now solve this, e raised to the power iota k minus m plus g x upon iota k minus m plus g. Then again e raised to the power iota k minus m minus g x upon iota k minus m minus g. This will go from 0 to L. V naught by 2L is equals to e raised to the power iota k minus m plus g L upon iota k minus m plus g. e raised to the power iota k minus m minus g upon iota k minus m g. Then this will be minus. If you put x is equals to 0, the about a numerator will become 1 iota k minus m plus g plus 1 upon iota k minus m minus 1g. So I could solve only this much because after that it will require a lot of calculation. And you need to find out the square of it, not this square of it. So let me do this question because I could solve only this much. If suppose you are getting answer of it, you can tell me. If I'll solve this question in this week, I can tell you. Okay? Okay, Harish? Okay. So now, how is your preparation going on? So from my side, this is the end. So I'll try to solve it after this. So this is the question like how is preparation going on for you all? Why? Okay. So how was it mock test? Okay, then prepare and because exam is coming, so prepare hard, huh? Best of luck to all.